My name is Barak Regev, and I lead cloud platform across EMEA. And not only you have the joy and the pain of having me as your MC for today, but I'm also your first speaker for the day. And following me, I'll invite Tom Gray, who is our lead for sales engineering across Europe, Middle East, and Africa for Cloud Platform Hill. And I hope that the first session will get things rocking for you. So I do want to talk in a little bit. I'll take 10, probably 12 minutes just to get to get you on the scene and what we want to talk to you about today, and to get that sense of where we're heading in this direction of cloud. We need to take you down memory lane 15 years back, and basically to see what happened when Google.com started off hitting a success in terms of search. Obviously, Larry and Sergey at that time and all the engineers working with them had to overcome a massive challenge in terms of technology fit. The technology out there in the market just couldn't make it happen for Google to work the way it wanted. Consistency, ability to scan the entire internet, hold endless amount of copies of it if you think, and really serve you the amazing results that you see in terms of content and in terms of accuracy and everything. And for that, Google over the last 15 years have really, and this is a great picture of a real data center, really this is what's behind the amazing, very simple search bar called Google.com. And it's a massive array of data centers spread out across the globe that provide you that service and all of us as consumers. And throughout the years, Google has obviously presented many other services. And if some of you are in other tracks, we have in parallel to this running a geo track. So you can see the logo of the Google Maps. So we have an offering for the enterprise and for businesses of taking our Google technology in terms of visualization and maps and providing it into the business. And many other services have evolved. And the common denominator for all of them, that we don't run any distinct data center for any of them. So they all run on that shared global infrastructure, which powers the power of Google.com. And this is the first thing that I want you to take away for those who are less familiar with our cloud, at least today, to understand that this is really one of our key differentiators out there in the market, that you're getting access to that same underlying technology that's powering the power of the web. And just to give you a sense on our journey to the cloud, we've done a good job in hiding a lot of the things we've done, and this is part of our process of starting to be a bit more visible and not to be shy about what we're doing. So just so you understand, and Stuart from Razorfish, which you'll hear later on, he told me he's been with App Engine since the day it was experimental, and that's 6 or 7 years ago. And we'll try and give you a quick update what has this journey meant for us, but just so to give you a bit perspective, as we speak, on a 30-day period, meaning from here 30 days back, we are serving currently on Google's cloud infrastructure around 4.75 million active applications. It's a very impressive number that if any of you are aware, it's one of the higher numbers out there in the market. And just so we understand, on one hand, you'll hear today an inspiring story and for example, on Argus and a project that Razorfish did. But on the other hand, major web assets like Snapchat, if any of you heard about, a massive ephemeral messaging platform out there in the market, probably as popular nowadays as WhatsApp and everything, is running completely in Google infrastructure. And that's one of the active applications. So that just to give you a bit of sense of the variety of applications running on us. And just to give you even a bit more sense, so we understand what it means to serve 4.75 million, and I just showed here Google App Engine, which are their platform as a service offering. Just so you understand, on a daily basis, we serve around 28 billion requests per day on App Engine. This is just, we get the perspective. I've written here what Wikipedia serves on that same level. So we are already, and my set of slides here are to convince you we have the scale, we have the experience, but yet alone, I feel, my leaders feel, my counterpart feel that still cloud as a general developer platform and as a hosting environment is still a bit too hard. And why is it too hard, or you might use the word difficult? It's because there's too many trade-offs happening out there in the cloud world as a reality of what different public cloud providers have created. On one hand, we hear a lot of feedback and comments that pricing is way too complex. You literally have to be a PhD in order to understand what's your monthly bill going to look like and anticipate it. On the other hand, I call it the developer and entrepreneur and enterprise architect dilemma. Do I go after time to market, or it's more important to focus on scalability? And then big data is on the drawing board of every VP, finance, CEO, regardless of the size of the company. We're working with gaming companies that are extremely small but have a huge install base of millions of users and really want to get to know their users better. On the other hand, we work with tons of retailers who want to, increase the in-shopping experience by doing real-time big data analysis. How do you do that? It's still crazy hard. And last but not least, it's, that's endless debate. Do I go after a platform as a service and really get the auto management and my weekends are safe and I know that Google is my SRE, or do I really want that flexibility that infrastructure as a service provides me where I can really play with the Lego building blocks like I'm used to? And that's what we say, that things deserve simplification. Now, I don't know how many of you heard the news last week, but I try to summarize it in 5 minutes for you, the key things that we announced last week in order to make the cloud a bit more friendly and a bit more compelling for any use case that you might look at. So I'll start with what the crowd loves. I call it the blood. It's the pricing. Everybody loves the war of pricing in some fashion. I wouldn't call it war, but I love the fact that I've been now with Google 4 years, and every year, prices are only going down. How fun is that, seriously, as a consumer? I worked previously in other companies where every year I had to convince customers why the price is increasing. So this is a different debate. And it's really important to understand why we think price should consistently decrease year over year. And it's very simple, Moore's law. Moore's law has proven over time that it's accurate, that hardware costs continue to drop, the amount of processing power is continue to exponentially grow. And as a fact, we've been looking at other cloud providers and ourselves, and on average, over the last 6 years, 7 years, cloud prices have been dropping 6 to 8% on average. Google is one of the biggest hardware, call it, consumers out there in the world, and we know as a fact, through the amount of RAM and everything that we buy, that there is way more price reduction happening through Moreline. That's towards 30 to 45% annually. It just doesn't make sense that these lines are not converging into one, or at least a bit more closer. And we were very happy last week to Spark, to try and reset pricing in the world of cloud, and we announced some massive price drops at the specific product level. So our infrastructure as a service VMs were dropping at 32%. Our storage, which is our object-oriented storage in the cloud, has been dropped by 68%. And then BigQuery, which is our big data analytical tool, by 85%. And I've written here what it means in essence. But it's not only about dropping the prices and making the unit extremely attractive for you. It's also about fulfilling the vision of cloud. At the end of the day, when everything started about cloud, it was all about the promise that you're going to get literally flexibility, elasticity, and you'll pay like we're paying for electricity. We will pay only for what we use. The reality has shifted a bit in that. Other cloud providers, in order for you to get a better deal, have started introducing a concept called reserved instances. And if you're willing to prepay 3 years in advance, bet on your future, tell me really how much VMs you think you'll need, I'll give you a very compelling price. It's created a lockdown scenario where many of you have committed for long-term relationships with cloud providers, and at the end of the day, you didn't get that flexibility because you've either under-provisioned, over-provisioned, and you're suddenly investing in CapEx, which you really didn't want to do. And we're extremely proud not only to drop our prices, but also to introduce a new concept that we think is more compatible to the world of cloud, and that's sustained use discount. What does it mean? We don't want you to prepay us. We don't want you to tell us how big of instances you will need from us, and based on your commitment, we will drop you the price. We will work the opposite. The more you use any of our instances, we will drop that price and give you that same discount you would have got in exchange for committing it in advance. We call this sustained use discounts. And basically, the graph here shows you what we've done with our pricing. So at first, we drop it for 32%. That shows you the drop from the red to the first point in around the 7 cents a dollar. And then, from the moment you start utilizing our VM, because yes, we agree, if you spin up an instance or a compute with us and run it steady state for a month, it's even cheaper for us to handle it and to manage it. So why not give you back that benefit and that cost saving? So don't commit to us. Don't put your hand in the pocket and give us the hard cash. On the contrary, use the VM for what you need. We will discount it at the end of the month. So very, very beautiful concept from my end that fulfills the destiny of what cloud is about. And basically, we did some more announcements. We introduced BigQuery fixed pricing as well. I cannot go into too much details given the time that we have. I urge you all to read our blog post. And to summarize, what we try to do with our pricing and resetting pricing is about reducing the monthly cost, simplifying, adding a bit of predictability, and obviously following the cost curve and really converging the Moore's Law curve and the actual cost of public cloud into one. So that's a massive step that we've done in terms of pricing and really creating simplicity. And we've done a lot of other stuff that obviously are a necessity for the evolution of cloud and utilization of our cloud by developers, architects, enterprises as a whole. First, we started expanding our support for Linux version. So basically nowadays, we announced a week ago the general availability of SUSE and Red Hat distribution systems running on Compute Engine. And with the other Linux supporting operating distribution system we support, we're basically nearly on the entire family of the Linux distribution family. But as you all know, first question, pedal stick. How many of you use .NET? Wow. Can I take a picture of that? This is a good picture. I see a lot of red, but I do see a bit of green. So I have great news for those who have said yes. We now support Windows Server on Compute Engine. Indeed, 2008 version R2, but it means you can now run Windows workloads and start doing funky stuff with .NET technology on our platform as well. I must say, based on the pedals, you are a minority .NET developers, but you can use our platform as well. So that's one thing that we've done in terms of enhancing the support and extending our platform, our infrastructure as a service. Now, next question. How many of you are already using any type of technology of platform as a service? Wow. Very impressive. How many are using infrastructure as a service technology? Doesn't have to be Google, can be anybody. Wow. Very impressive. I must say I'm very surprised with the amount of greens that platform as a service received. Kudos to you guys, but that's exactly the dilemma here. Flexibility, management, and productivity. That's exactly what we call the developer dilemma. And again, the continuum of computing, as we call it, we introduced last week. I find this cutting-edge breakthrough technology really in the world of cloud for those who are engaged. But this is manageable virtual machines, meaning I can start using my platform as a service, let's say App Engine. And App Engine supports Java, Python, Go, PHP. What happens if I need to run some arbitrary code, let's say in C language? How do I do that? Usually, drop the platform as a service. Let's go develop everything on infrastructure as a service with all the headache. There's news. Manage virtual machines, meaning you can call through your platform as a service, our App Engine, tell him, spin up a few VMs, run this code, integrate it as part of the application, and run it for me, manage it for me. In a way, getting the both of two worlds. So again, it's not a complete answer for that dilemma of flexibility versus manageability, but it is a first step in solving that. And last but not least, how many of you are doing big data projects? Okay, as I suspected, entry level. How many are doing real-time big data analysis? How many agree that it's crazy hard? Thank you. We're gonna hear later a presentation by our partner DataSift that I hope that will articulate that you can do actually real-time analysis and it's not that crazy hard. But we did introduce a great feature called BigQuery Streaming API, which means that you can now stream 100,000 rows per second in real time into our data repository. Add to that our price drop, and now you can get a very easy, affordable, real-time big data architecture out there. And one of the things that we presented, and for the sake of time, I couldn't show it today, we have a great demo that a real project from the city of Seattle where you got an intelligent network with smart metering, literally sending real-time events, not 100,000 rows, but actually 2,000 events per second, and giving you a real-time analysis of outage analysis, anomaly detection, consumer support, financial reporting. So this is the reality, and big data is about data insights. A lot of people invest so much time in technology and resources in just setting the architecture and the infrastructure, but they're left breathless in terms of really doing the data analytics. So this has been a fast update for you on where cloud is going, what we've announced, a little bit of understanding how the cloud platform integrates to the greater Google. But without further ado, I'd like to go a little bit deeper and invite Tom Gray to tell you what the story on how you architect on the cloud.
Thank you, Barak. Who here works as an architect? Use your paddle-y. Ah, he's stolen my paddle. Barak has taken his paddle home already. Cool. Who here works as a developer? Okay, cool. So I was going to give you a bit of a perspective as a former architect on what I think cloud perhaps means for us as a profession. Why indeed would you want to architect on the cloud? And I was going to start by telling a little story. So back before I worked here at Google, I used to work for a large systems integrator. I won't say who, protect the innocent. But I was outsourced to the Department of the Environment, and I was charged with working on a system to do tracking of sheep and goats, which is pretty cool, I thought. I was like, I'll do that. Yeah, we were a smart bunch of people. We were sitting on a ex-World War II hospital site on the outskirts of Guildford. No real air conditioning, no real heating to speak of. Seemed to heat it when it was hot and cool it when it was cold. But we were co-located, and we should have been a pretty happy bunch of people. We were a smart bunch of people. We had an interesting project to work on, and we kind of were. There was something that always nagged me, and it nagged me a lot as a lead developer, which was the customer never seemed to be completely happy. They always seemed to feel that things cost too much money. If you knew who the systems integrator was, that probably wouldn't surprise you. But what irked me more a little was that they always used to feel everything was too slow. And we used to joke that they used to think that we sat around in there sipping cocktails rather than doing our work. And I used to think about this a lot. And it occurred to me that what I had was a problem with what I think of as the IT iceberg. And really the IT iceberg says that if you think about all the things that you do, you have this huge piece of work to do. But all your customers ever see is the little tip of the iceberg that sticks out. That's why they thought we were drinking cocktails, because all they ever saw was the little bit of what we did that stuck above the waterline. And if you think about why that might be, you think about all the things you need to do to build a computer system. So you need physical hosting, you need electricity, you need cooling, you need security, you need fire protection. I always say, as an ex-developer, I don't know much about hardware, but it always seems to catch fire. That's the only thing I ever know about it. You get all of that in place. You then need to fill that room up with servers. So somebody on the project had to buy servers. Somebody on the project had to make sure there were floor plates. Somebody had to make sure that they weren't going to exceed the electricity requirements. When they turn them all on, we weren't going to blow all the fuses. We need to buy tape. We need to buy backup systems. On top of all of that, now we've got a whole room full of servers, but not going to do anything until we put some kind of software on there. So we need to make sure we've got software. We need to make sure we've got all the right versions of the software. We need to make sure all of those versions are going to play nicely together, and then we can patch them and keep them all up to date. At that point, we could start thinking about some services to run on that. So maybe we're going to have some generic services around, perhaps mail or some tape backup and things like that. And at that point, we can actually build our app. So we can write our code, we can write our libraries. But actually, that's not the top of what we're trying to do here. What we're trying to do here is we're trying to have some kind of a business outcome for our customer. We're trying to track sheep and goats. We're trying to make happy place for farmers who have one of the highest suicide rates of any profession, which is a bit depressing. So there you go. It's not the way they show it on kids' TV. But if you think about all of that, from the point of view of the Department of the Environment, this little bit up here was the only bit they're really interested in, right? This, arguably, is differentiating. You don't have a huge amount of competition as the Department of the Environment, but you've still got to do a good job. All of this is just a means to an end. All of this is cost. And that's the iceberg. What you see, what the customer sees is the tiny tip up here, but what you do is all of the work that goes into supporting that. So what we're trying to do with Google Cloud Platform is trying to solve that problem. And what we're doing is we're trying to, as Barak said, externalize what we've been building internally for the last 15 years and how we've tried to solve that problem inside of Google. And we're a pretty secretive bunch at Google. We haven't talked much about what we do, but we have released a few papers. So some of you will have heard of GFS. Some of you will have heard of MapReduce. So those two papers inspired Doug Cutting to create Hadoop. Hadoop has gone on to become a very, very rich ecosystem and something of a buzzword in its own right. We also released a paper on Bigtable. So Bigtable arguably triggered the whole NoSQL movement. And we're externalizing those things, and we're making them available in a user-friendly format. So let's dive into that a little bit. So if we think of the Google Cloud Platform, the common element here, because we're dealing with cloud, is the internet. Everything is delivered over the internet. And we typically have three populations sitting on the other side of that. So we have customers, your customers. You connect to Snapchat. You're connecting to Snapchat as an application, but you're accessing Google servers. You work for BBVA, and you connect to the company portal. It's the BBVA portal, but it's running on servers owned by Google. And lastly, more and more customers' products as well. So we're seeing more and more people building Google Cloud Platform components into their own products. So at one end, we have Google App Engine. So Google App Engine is platform as a service. So you build your code in Java, Python, or PHP, and you conform to some basic rules. But by conforming to those, what we do in exchange is we entirely run that for you. We pretty much take the entire operation of that, and we take it on ourselves. So we're responsible for backing it up. We're responsible for scaling it out. We're responsible for making sure that if it falls over, it gets put back on its feet again. The other side, we have Google Compute Engine, which is infrastructure as a service. So spin up virtual machines, networks in the cloud in vast numbers. And then we have, hello. We have some components in the middle. So we have data storage spun out as Google Cloud Storage, so object storage in the cloud. So you can durably, resiliently store objects up to 5 terabytes in size. Google Cloud Data Store, rumored to be the world's largest public NoSQL data store. And Google Cloud Storage, managed by SQL in the cloud. And then finally, Google BigQuery. So Google BigQuery externalizes a service we developed internally called Dremel. And Google BigQuery allows you to run SQL queries over huge, huge data sets and get back an answer in interactive timescales. And all of you may be thinking, I can kind of see how that helps a little bit with the pyramid problem. But what's it all about? Who here has come across the tree swing? I love the tree swing. So one of the other things I learned while I was tracking sheep and goats was all to laugh at the tree swing. It's funny because it's true. But actually, if you think about the way that development's normally done nowadays, the idea of having iterative cycles of development where you go away, you do some design, you disappear off, you come back, and you present it to the customer, is pretty out of fashion. Everybody nowadays does agile development. And that, I think, is why cloud is so exciting. Because cloud gives us the ability, I think, to have agile infrastructure. It allows us to experiment in a way that we never could before. So this is Urs at Google I/O 2 years ago now. And Urs did quite a cool demonstration. So Urs, whilst he was presenting, spun up this simulation. And his simulation is looking for interactions between different human genomes. And at the start of his presentation, it was finding maybe 1 interaction a minute, 2 interactions a minute. And over the course of his presentation, he added more and more cores to this simulation. By the time he finished speaking, it was finding tens of interactions per second. And the reason for that, and 2 years later, I'm still cross with Urs for standing in front of the single most important detail on this slide, which is very inconsiderate of him. But if he would just do us a favor and shift somewhat to the right, we'd see that actually this simulation is now running on 600,000 cores. Somebody in the press speculated, they did some research, they speculated that for the duration of this presentation, this was the third largest supercomputer in the world, which is pretty awesome. So my question to you then is, how would you architect differently if you could use 600,000 cores, especially if you could borrow them and pay by the minute? So I think you would be a little bit happier to experiment. You can afford to experiment because you don't need to worry so much about how much capacity you're going to need. You don't have to worry so much about overcapacity or undercapacity. And if the whole thing doesn't pan out for you, you can just stop it at any time. You don't have to justify why you've now got to sell 30 servers on eBay. I'd speculate that it'll make you think differently about resilience. So whenever people talk about cloud as an architect, we talk a lot about resilience and designing for failure. And I think we've done a bit of a disservice there because I think we've created the perception that cloud is somehow inherently flaky. It doesn't have to be inherently flaky. It shouldn't be inherently flaky. Sometimes it is, but that is a problem that needs to be fixed. The reason I think that it's important, and the reason I think we should talk about it, is because if you have 600,000 cores and you can pay for them by the minute, if something does blow up, and things always do from time to time, why on earth wouldn't you replace it? Why on earth wouldn't you design for failure? Why wouldn't you build something into your system to throw away that dead machine onto a scrap heap somewhere, stop paying for it, and pick up a new one that works? And lastly, I guess a lot of you will probably be familiar with workloads like this. So you have very, very spiky workloads. Maybe this is Snapchat. Maybe you won't ask what the peak is. But maybe it's East Coast coming online, of course. Or you have something like this. You're popular, and you keep getting more and more popular. Traditionally, to tackle something like that, you either have to plan for the worst-case scenario, or you have to constantly keep adding in hardware. But I would say if you've got 600,000 cores available, and you can rent them by the minute, you'd be bonkers not to try and build something in to take advantage of the ability to scale up and scale down. So I think cloud has some things to offer. If we think about cloud in terms of the volume of work you have to do and the predictability of that work, cloud is really, really great when you have scale problems. So you need lots and lots of machines. Cloud is really great when you have elasticity. So you need more machines sometimes and less at other times. But I think really, perhaps, when it's most important, is it gives you flexibility. It gives you flexibility to try things out. It gives you flexibility to change things on the fly. So a couple of case studies to finish. So the Met Office built something called the Weather Observation website. They worked with a consultancy called PA Consulting, some of you will be familiar with. And what the Met Office wanted to do was they wanted to work more closely with some of their most ardent fans. Some of their most ardent fans are amateur weather enthusiasts. I'm pausing because I'm thinking, shall I ask you who's an amateur weather enthusiast in the audience? Is that a fair question? Yay, cool. And Barak is as well. Oh, no. OK, Barak's not. OK. So amateur weather enthusiasts take weather observations, and what they really wanted was to have somewhere where they could submit their web observations. And so the Met Office built this site, and this site takes in weather observations, and it makes them public, and it crowdsources them. And they got some very, very interesting data out of it in the purposes of doing that. But what's actually interesting is they didn't really know if this was going to be a success or not. It was almost something of an experiment. And yet now, in the first year, 136 countries and 25 million weather reports were filed. And yet the whole thing was built by 7 developers from PA Consulting in just 5 months. Best Buy. We can now use far fewer developers, and we don't have to spend any time doing system administration or setting up servers, which allows us to focus on the development and testing of new ideas. Developing apps on Google App Engine takes 1/4 to 1/10 the resources and 1/4 the time compared to building something ourselves. Gaelic Howling gets it. So I'd say my challenge to you is, what would you do if you were building on the cloud? What can the cloud allow you to do differently? Thank you.